Continuing on in section 2.4, an equation that is true for every possible value of the variable is an identity. An equation has no solution if there's no value of the variable that makes the equation true. And it's an identity if it's true for every possible value. What's the solution of each equation here? Well, on the left side, we're as simple as we can get it. On our right side, we can simplify here. We got to get rid of those parentheses, and I do that by distributing. I take the 2 times 5x, because I'm multiplying the 2 right now, and the 2 times 6, which gives me 10x plus 12. Left side is as simple as I can get it, and my right side is as simple as I can get it. So now I can move all my variables together to one side. I have a positive 10x. I take 10x away, and whatever I do to one side, I do to both. Keep in mind here, 10 minus 10 is 0 x's. 10 minus 10 is 0. So all I have left is 12 equals 12, and that is true. So since it's true, we call this an identity. And we say that there are infinitely many solutions. And we can remember that because both sides are identical, so it's an identity. In B here, my left side is as simple as I can get it. My right side is not. I don't have any parentheses here, but I do have like terms. So as long as they're from the same expression on the same side and same team, we just add them up exactly as they're written. Negative 3 plus 12 gives me 9m. We don't do the opposite unless we're moving to the opposite side of the equation. Now, left side's as simple as I can get it, right side's as simple as I can get it. I can subtract 9m to get my variables together. Positive 9 minus 9 gives me 0. Positive 9 minus 9 gives me 0. My m's have canceled out. I have no more m's. Negative 4 equals 5. Here, negative 4 does not equal 5, so we say that there is no solution. There's no value for x that we can plug in here to make this a true statement. You can also do this little symbol right here, which is a null set or an empty set, means the same thing. So again, anytime our variables completely cancel out and we have either a true or a false statement, not an open statement, a true or a false statement, it's either true, which means an identity with infinitely many solutions, or false, which means there's no solution. Feel free to pause here and give A a try if you'd like. My left expression is not simplified. Here I can simplify it though by distributing. I take that 3 that's being multiplied times that difference and I take it to each piece in my difference, each term. Take the sign with your 2 there. And I get 12b minus 6. My right expression is as simple as I can get it. Negative 6 plus 12b. There's nothing else I can do there to simplify it any further. Now, left side's as simple as I can get it, right side's as simple as I can get it. I can start moving from one side to the next. And I'm going to move my variables together. I have 12b, I get rid of 12b by subtracting it. Right now it's a positive 12, so I get rid of it by doing the opposite and subtracting. Whatever I do to one side, I still do to both. 12 minus 12 is 0, and 12 minus 12 is 0. I have negative 6 equals negative 6. This is true. Both sides are identical, so we call it an identity, and we say that there's infinitely many solutions. Okay, we can plug in any x we want to there, and we will get a solution, because whatever happens to one side, the same things are going to happen on the other. It might not look the same, but eventually it'll do the same things, and we'll get down to an equivalent expression. Here, my left expression is as simple as I can get it. My right expression is not. I'm going to distribute negative 1 times 3 and negative 1 times negative 2x. Negative 3 and a positive 2x. Negative times a negative. Don't forget to take those signs with those numbers. Negative times a negative gives me a positive. And again, we said left was as simple as we can get it. Now that both expressions are completely simplified, I can move from one side to the other. Subtract 2 to get my x's to be 0 on the right side or the left side. 2 minus 2 is 0, and 2 minus 2 is 0. All I have left now is 7 equals negative 3, which is not true. 7 does not equal negative 3. So here, our answer is no solution, or you can use your symbol there for empty set or null set. So again, anytime we have a variable left, we get like x equals 4, for example. That's an open statement. That's just our solution. Anytime our variable completely cancels out, though, and we have no more variable left, it either gives us a true statement or a false statement. If it's true, it's an identity because both sides are identical. We call it infinitely many solutions. If it's false, like 7 equals negative 3, for example, no solution there because no matter what we plug in for our variables, we're never going to get to the same spot. 7 is never going to equal negative 3. Take note here on page 105 is solving equations, and these are going to be our steps for solving equations every time. First couple things we're going to do is just simplifying our expressions. So simplifying our left expression and our right expression. We're going to check for if there's any parentheses and get rid of them by distributing if we can. Then we'll combine like terms on each side if we can. So if there's 2 x terms or 2 constant terms on the left side, we add those up exactly as they're written. Once our left and right sides are both as simple as we can get them, we're going to start solving. And this is where we move from one side to the other. We use properties of equality to get our variable terms on one side and constants on the other. So we move all of our x's one way and then add or subtract to get all of our constants, just our number parts, to the other. And then we use our properties of equality to solve. A lot of times it'll be multiplying or dividing here. Last thing we're going to do is we are going to plug our answer back into our original equation, the very first equation we have, to double check and make sure we're right. If both sides equal, we're correct. If they don't, either you did some of your math wrong when you checked it or when you solved it. So we know there whether we are right or not. Quick recap here. Equivalent equations are equations that have the same solution. The solution of an equation with variables on both sides can be found using the properties of equality and inverse operations to form a series of simpler equations. And the properties of equality can be used repeatedly to isolate the variable. And that's all I have here for section 2.4.